So let's talk about electric field lines. So a lot of times they'll say for the rules that the electric field, so the electric field overall will point away from positive charge and toward a negative charge overall. Okay, something to that effect. So one way to look at it is if I gave you a positive charge, and let's say an electric field was blasting this particular way, well, then my first question to you is conceptually, what is the direction of the electric force on that charge from the electric field? So which way is the electric force pointing on this charge? It's pointing the same direction as the electric field, okay? And again, what they say in general is it points away from a positive and toward a negative. So one way to reason this is I would say, you know what, the electric field is probably coming from a positive charge plate and going toward a negative charge plate. So that's another way to conceptualize. If you're not sure overall, then go ahead and if the electric field lines are pointing away from a positive toward a negative, draw a positive plate and a negative plate, and you can see that these are going to repel, and then the positive and negative are going to attract. And that might help you overall draw that visual to help you out with what's going on. Because eventually what will happen is you'll get some type of question, conceptually on some type of assessment, a quiz or a test, where they'll give you some type of like three-dimensional problem like this. And they'll talk about, okay, we've got, let's say a positive charge here and a negative charge here. And let's say we got a point out in space and we want to know what the electric field is. And we'll assume the magnitudes are equal to each other. And so they'll say, what's the magnitude of the electric force at this point right here, given that these are the same charges, just one's positive and one's negative? Well, again, you would say it's going to go away from a positive and toward a negative. So this is charge 1, that would be E1. If this is charge 2, that would be E2. And overall, which way is it pointing? Well, again, if these are the same magnitude, well, then I would see that the electric field in the y direction would equal 0, to cancel, because up and down, remember, electric fields are vectors. They would cancel, and the electric field in the x direction would be going to the right and to the right. So therefore, I know the final answer is going to the right. And this is how they'll start to ask you the types of conceptual questions without actually putting any numbers in them overall. Another concept you could be asked is they could give you something along the lines of, say, even one dimension and say, okay, given the following here, let's say we had a positive charge Q and a negative charge, we'll say just negative Q, and they ask you maybe something like, what is the direction of the electric field right here? So again, we have charge 1, charge 2, it points away from a positive, let's see, so that would be E1 and toward a negative E2, but here's the problem now. On the previous example, the reason why this worked out is because we're assuming these distances were the same. So we're looking at the equation KQ over R squared. Over here, though, even though the charges are the same, the distances are different. So using the equation equals KQ over R squared, which one of these is larger? Well, if the distance is larger, given this ratio, that means that the magnitude of the electric field will be smaller. So the further it is away, the less of an electric field it's going to have. So that means that this field E1, since it's from charge 1, is further away than this charge E2. So since that's the case, we could say that, well, it looks like E2, the magnitude of E2 is going to be bigger than the magnitude of E1. So therefore, that means the final direction of electric field between these two charges at this point in space is pointing to the left, or the negative x direction. And that's just a few different examples you can look at conceptually.